Hey, it's me, Tian Tring the Chemist. Welcome back to Dangerous Lab. Today we're going to make one of the most affordable desiccants for amateur labs. A desiccant is very useful in many experiments. We're going to make anhydrous magnesium sulfate by dehydration of Epsom salt, which is the heptahydrate form of magnesium sulfate. The steps for this experiment are pretty straightforward. I've included a timestamp in the description. Feel free to skip to the part you need. This is a relatively simple experiment. I will, however, include many tips and tricks, things to avoid, and a detailed explanation along with the experiment, so be sure to stay till the end. Before the start of the experiment, a quick disclaimer.
Do not eat the Epsom salt. The oven is hot. Do not touch it.
For this experiment, you will need Epsom salt, which is bath salt that's usually available in pharmacies and supermarkets. It's usually quite cheap, but be aware, only use the unscented version though. Aluminium foil for making a baking tray, or just buy a pre-made aluminium foil baking tray. An oven that is capable of heating up to 250 degrees Celsius. I'm using a pizza oven in this video, since it has the highest operating temperature of 350 degrees Celsius, which allows me to experiment with more temperature configurations. However, you don't need this kind of temperature on your oven. An optional Ziploc bag to store the product. I'll start the experiment by weighing out 3 batches of 50 grams of Epsom salt, so I can get a baseline of how much water is lost at different temperatures. Since I already do the heavy lifting for you, if you decide to repeat this experiment, you can use the recommended configuration later in this video. Each 50 grams of Epsom salt is weighted on a weighing boat. I will be using 3 different temperatures for the dehydration: 230, 250, and 270 degrees Celsius. These are temperatures commonly available on home ovens, or were often used by the papers about dehydration of magnesium sulfate, so I will be testing it out and see how the results go. Let's get started as I will explain along. The first batch of Epsom salt is placed in the oven, heating it to 230 degrees Celsius, and it will be heated for 2 hours. The second batch and third batch will be heated in the same manner, with 250 and 270 degrees Celsius respectively. According to this book, magnesium sulfate starts losing its first 4 water molecules at 70 to 80 degrees Celsius, the 5th water at 100 degrees Celsius, 6th water at 120 degrees Celsius. The last one is pretty tough to lose though. It turns anhydrous at around 250 degrees Celsius. I heated the third batch at 270 degrees Celsius, which is 20 degrees higher than the literature value, just to be sure it will turn anhydrous. And as a comparison to 250 degrees Celsius, all 3 batches of Epsom salt has been pre-weighed with the aluminium foil, and the final mass obtained after heating at different temperatures are shown on screen. For the theoretical anhydrous form, the mass should be reduced to about 48.8% of the original mass, as you can see from the results. Heating at 250 degrees Celsius or above will reduce the mass to around 49.2%. Which is within the margin of error. So that is pretty much the anhydrous form. And heating at 230 degrees Celsius failed to drive the last bit of water molecules away. From the result I obtained from the small-scale experiment, I can conclude that heating at 250 degrees Celsius gives the best result, as heating at 270 degrees Celsius provides little to no benefit. Heating for 250 degrees Celsius for 2 hours is the most reliable settings from the result. You can get away in about an hour of heating. However, it largely depends on the amount of Epsom salt you use and the overall thickness of it. 2 hours of heating at 250 degrees Celsius usually yield the best result. This experiment has been demonstrated by a few other YouTubers. I do think there are a few key points that are missing, so be sure to watch closely for the next few chapters. Firstly, I would recommend using aluminum foil as a tray for the Epsom salt, as the magnesium sulfate crystals tend to harden as they dehydrate. It also has a tendency to stick to the oven tray. Having a layer of aluminum foil will mobilize the crystal and allow you to easily crush the crystals afterwards. Secondly, I would recommend using Ziploc bag for storage. Transfer a product on the aluminum tray to an appropriate sized Ziploc bag. What a seamless experience. You can then crush the crystal all inside the bag and save yourself some cleaning time. This also limits the time it is exposed to moist air, which is always good.
I reached about 420 AR-15s on mine. After that, it started to get kind of a brown color.
Be careful not to heat it up too much. I found that my oven was a little erratic, and when I raised it to 250, sometimes it burned the magnesium sulfate.
If you are seeing your end product turn slightly off-white or even brown, it is completely normal. No, it is not. You should definitely consider cleaning an oven, or just don't use your kitchen oven at all for chemistry projects. Get yourself a new one. I'm demonstrating what you can get with a kitchen oven. As you can see, the Epsom salt I baked in my kitchen oven turns brown as well. I never wanted to use a kitchen oven for chemistry, not because my chemicals are toxic. It is because I don't want my kitchen oven to contaminate my chemicals. The off-white or brown colors are mostly from oil and grease vaporized it and deposited onto the magnesium sulfate. I wouldn't recommend using this off-white magnesium sulfate for any chemistry experiments, since it will mess up your yield and purity. As you can see, anhydrous magnesium sulfate quickly absorbs moisture from the air and gains weight very quickly. It's not worth weighing to calculate the degree of hydration if you just intend to use it as a desiccant. In theory, you can pre-weigh the Ziploc bag so you can weigh the whole bag and close it to obtain the actual mass. You may also wonder why Epsom salt is sold in its septahydrate form, but not in the anhydrous form. The first and most important reason is that the seller can scam you because 51% of its weight is water. No, seriously, check out what happens when I add water to Epsom salt and anhydrous magnesium sulfate respectively. Epsom salt gracefully dissolves in water, and anhydrous magnesium sulfate absorbs all the water, hardens to a solid chunk, and releases a lot of heat. I guess you don't want to turn your bath into a hot spring, right? The hydration process is so exothermic that I can literally warm up my lunch with it. It is optional to crush the powder, but if you need to crush it, just do it inside the bag with a pestle. Don't pour it out to crush it with mortar and pestle, as it is so hygroscopic that it could ruin your end product. Also, I find it absorbs moisture faster when it's in powder form, so it is best to keep it in chunks if you want to prolong its shelf life. You can either store your final product in a Ziploc bag or transfer it to a bottle if you will. Either way should be fine. This is the first video in one of my upcoming video series. Subscribe if you want to see it in the future. And also be sure to drop a like for the algorithm. Remember to stay curious. And I will see you in the next one.